Surprising amount of people. I don't think anyone got like.
No, they all just giving a chance on notes and you was in the document, like I think the bad it's just the value type one yeah.
Just for the residents.
Yeah, they
Just for the residents. Not like, yeah, this one. No, I mean, different too. It's not minus. It's 40.
Yeah.
And then I guess you join like.
Like a safe.
Are you taking it? You did? Yeah, but no, you shouldn't be taking this. It's free. Anybody can pull it. The school day when they.
Yeah, exactly, and they're also. Highly valued. That's easier.
Have you seen them get projects started in 2016?
Yes.
Trust, I got three. That was very funny. That was a bad. Stuff like.
All right.
That's just. You start off with nonsense stuff.
So we're now in review mode. Let me kind of highlight what's coming up. I want us to focus some time on specific BC FRQs or BC only FRQs. And I feel like, well, since Taylor series is pretty fresh in our mind, let's just spend the time to see all, we'll see some variations of Taylor series FRQs. So we'll spend our time doing that today and next Thursday. In your packet, there's also these particle motion parametric related FRQs. So we'll spend time next Friday doing that. Next Friday and next Monday, or not next Friday and the following Monday. And then we're just going to continue working through these FRQs. And as you go through the problems in your packets, each day will be worth 5 points. And then we'll also have a second packet coming up with just a lot of AB topics in there. And we may be, some of it may be repeated things that we've already done, but we're just going to continue going through those practice, and they'll count towards the 50 homework points of the first review test that's coming up. And that's just going to be over, it'll be one Taylor series FRQ and one particle motion parametric FRQ. And that'll be worth 50 points. And then the homework between the first packet and the second packet I'll give you after next week, that'll count towards the other 50 points, and that'll count towards 100-point test grade. Okay, so that's going to be the first test. And then after, I don't have the calendar for April for you guys yet, but in April, after we come back from, well, actually, after this, we're going to try to just do a review over all the major topics, kind of highlight over all the major topics in the week leading up to spring break. And then after spring break, I want us to focus on miscellaneous BC FRQs, like Euler's method and things like that, and then also polar. So we'll have a quiz over those two specific topics in the middle of April, and then we're going to prepare for a multiple choice test, and they'll split up into 2 days. Both will be 30 minutes because it'll be during that week when we have adjusted schedule due to end of course testing. So 30 minutes for like 10 multiple choice questions, 8 AB topics, and then the second day multiple choice quiz or test, 10 problems over BC topics. And that with the 2 multiple choice will combine to be a test grade. And then and that will be the last in-class test assessment that we take. I'm going to give you some more packets, but then those will just be take-home problems for you to finish. And you turn that in before the end of the school year, and then those will both count as individual quiz grades. So those should be easy 100 quiz grades just by entering that in. So I think I'm looking at 5 assessment grades going to the grade book from now until end of school year. So we have 3 in-class assessments, 2 tests, 1 quiz, and then 2 take-home quiz grades. Yeah, all the assessments I'm going to give you, some of them may be calculator, some may be non-calculator portion. I'm going to let you use your calculator for everything, but just with the non-calculator section, I'll ask you to show me work. And I'll go over more details about the format of the AP exam once you get a little bit closer. Any questions that you guys have right now?
For like, so for like the AB topics, like units 1 through 3,
Yeah.
I think like one day would be like sufficient to cover all of them.
Oh, we're gonna spend a couple days. So limits, continuity, differentiation, related rates. We'll spend 1 day doing that. Then we'll do another day doing MBT, roles, curve sketching. And then we'll spend another day going over just miscellaneous things that maybe like area volume. So I think we'll spend like 3 days going over AB topics. And then we'll spend 3 days or maybe if we need more time for AB, we can do that here and do less here because this should be more familiar to us. But I think, you know, a week and change should be enough for us to kind of have an overview over the entire year.
So is our FRQ completely like different than the AB one, or do we also take the AB and then a BC portion on top of it?
Oh, you're talking about on the AP exam?
Yeah.
So on the AP exam, you're going to share 3 FRQs between AB and BC. So, but we don't know which, which 3 they will be. And then, but BC is usually, you're going to have guaranteed Taylor series. And you're most likely going to have like a parametric polar particle motion. And then that 3rd FRQ can either be an AB topic, or it could be a mixture of AB and BC. It could be polar. Polar doesn't show up every year as an FRQ. I mean, you're going to see it in one form or another, but it may not be an FRQ form. It may be on the multiple choice. And in recent years, I feel like they've been doing a better job of kind of mixing things. So even though there's a category for like, oh, this is Riemann sums, they will, try to do a good job of kind of mixing different BC topics into like part C or D of the problem. So hopefully, we have all the FRQs available to us. We can look at some of the more recent ones and kind of see some patterns that can be helpful for us.
You know the date of the exam?
Yeah, it's going to be May 13th. It's going to be a Monday. So AB, BC, AP Pre-Calc, they're all going to be testing on the same day. All on the same day, Monday. Yeah, this year's a little bit interesting because normally AP exam starts the first week of May. And this year, because May 1st lands on like a Tuesday or Wednesday, they're starting AP exams on the 2nd week of May. So this year is like late. It's like 2nd and 3rd week instead of 1st and 2nd week of May. So. All right. Any other questions? Okay. All right, let's see if we can maybe get through a few problems. All right, so I'll walk us through the first one and then and continue. Hopefully, get through 3. Yeah, the goal is to get through 3 today. So part A says find the first 5 terms in the Taylor series about x equals 0. On my key, I built it from scratch, but what we could do is, recognize this as kind of like a geometric series. Because it's centered at 0, we can kind of just build out the first few terms that way. So I'm going to do it that way, different than the key. But it's good to know both ways in case something is not centered at 0 and having to build it from scratch is useful. But I'm going to do it a different way than the key so that we have some different varieties.
Is it like any mode that gives the derivative, like the general derivative?
No, we can't. TI 8384 can't take an indefinite integral. Can only do a definite integral. Is that what you're asking?
Talk about derivatives.
Yeah, it can't do derivatives. It can evaluate the derivative at a point, but it can't find the derivative for you. Right. So I know my first term is 1, and then my ratio is 2x. So I'm just going to keep multiplying by 2x to every subsequent term. Oh, factorials. We could. That's how I did it on the key. But because I can recognize this as something that we can build from one of the patterns that we know. Well, the pattern has a shortcut basically, right? With like the sine, the cosine, e to the x. Those are, we can do that because it's a Maclaurin. But if it wasn't, then yeah. But I worked it out that way on the key. So technically there are factorials, but it just cleans up to that. Yeah. Okay. But again, I want us to be flexible to be able to know both how to do both. But right now I'm just showing the quicker way. Oh, it wants the first 5 terms. I need one more, sorry. Or I'm just write it out here.
We have to do the a sub 1 over 1 minus r. If I like remember, it's just x to the n, right? Like, or do I have to like show? That
Oh, you mean the summation?
Like above the a1 over 1 minus r.
We don't have to. No, I just wanted to show that, okay, this is what I'm doing with geometry series to pull the a sub 1 and the r.
That's from the pack. I just remember it's just x to the n.
That's fine. Yeah, you can do it that way too. I like this. Just to me, that comes more easily to me, but your way works. Part B, find the interval of convergence. So I'll do this both ways. We can go through a ratio test. a sub n plus 1 divided by a sub n. The n's cancel out. I'm just left with a leftover 2x up in the numerator. So absolute value of 2x is less than 1, which means that the absolute value of x is less than 1/2, which means that x is going to live between negative 1/2 and 1/2. And I can test my endpoints. If I plug negative 1/2 in for x, I get negative 1 to the nth power. So that's negative 1 plus 1 minus 1 plus 1. That's going to diverge because nth term test is not going to give me 0. If I plug 1/2 in, that's just 1 to the nth power. The limit of n as n approach infinity, but do nth term test on that, that's also diverges. So the endpoints are not defined. So interval convergence is just going to be between negative 1/2 and 1/2. Another way to understand this is that this is a geometric series, basically. So with a geometric series, if my ratio is 2x, then the only way that I'm going to get convergence is if my ratio is less than 1. So the absolute value of x is less than 1/2. So the endpoints are never defined or never converges for geometric series. So that's another way for us to know that the endpoints are not going to diverge, are not going to converge, but will diverge. Part C, use partial fractions and the results from part A to find the first 5 terms in the Taylor series. So partial fraction, let's review that. So partial fraction, the idea is that we want to take a denominator that is multiplied and split them up into the sum of 2 separate denominators. So I know I want it to look like a over 1 minus 2x plus b over 1 minus x. Right. The way I like to do this is do the cover-up method. So find the factors for each denominator, solve for x. And by cover-up method, I'm going to cover up the 1 minus 2x when I insert 1/2 into the rest of the remaining fraction. Don't forget about the numerator. So it's 1 over 1 minus 1/2. What does that reduce to be? 2. So a is just equal to 2. Same thing here with 1 minus x. I'm going to cover up 1 minus x, replace my remaining x with 1. Don't forget about the numerator here. Don't just do the denominator and be done with it. It's the numerator divided by the denominator. So 1 over 1 minus 2, what does that come out to be? -1, yeah. So b equals -1. So we know g of x is simply half. Oops, sorry. 2, not 1/2, my bad. I was looking at down here. A is 2. Now, if you look, these are both in the form of geometric series. So we can just find the sum that way. We can find the each of these in polynomial form, and then we can just merge together and find the first 5 terms. Or how about this? I can break this into something, break it up into multiple steps here.
So for part B, when testing ends, do you have to like justify, oh, by nth term test? By A is 2.
Hmm. Good question. I want to say that that all they care about is for you to know how to get to the right answer. But you don't necessarily have to justify it. Let me get back to you on that. I want to look at the scoring guidelines from previous problems and see if they take off points if they don't show justification for the endpoints. So, okay, yeah. So I'm basically just going to take this and then combine it with this and see if I can merge terms together so that I can clean it up and show the reduced or the cleaned up first 5 terms of the resulting sums added together. Enos, to answer your question, I think the second problem will answer your question because it will say justify your reasoning, and that justify your reasoning would mean then that when you test your endpoints that you're telling why those endpoints converge or diverge. So I think in the instructions they will reference that they want to see your work. But if they don't reference it, then I would still put the reasoning down, but I don't think they will take off points if they don't ask you for the reasoning.
Usually like the endpoints, they'll be like simple tests.
They're usually simple tests, right? Usually like AST or nth term. Yeah.
Yeah.
Usually it's just going to be pretty simple ones. Okay, are we good with number one? Right. Number two. So basically, from now on, anything that we do in class is just going to be part of your classwork slash homework. So anything we do in class, we're just trying to complete a portion of the homework, if not all the homework, and then the rest of you do at home. That's basically it. And then everything that we do is also just basically your earning points towards your assessment grade as well. Okay, so I'm just gonna let us work on our own, and I'll work up here on the board as well.
How do you know the upper limit of natural log and natural log of 7.1?
Because these are both the same degrees, I can just basically ignore that +2, right? That +2 and +3 is not as significant as that k. So basically, they're in the same degree. And the coefficient is 1, so I can just drop them out.
Okay.
Yeah.
So if you have like 2 natural log of k plus 2 over just natural log of k plus 3, then it'd be infinity.
Wait, say it again.
So if you had 2 natural log of k plus 2 over just natural log of k plus 3, would the limit would be?
I think of natural log of k plus 2 and natural log of k plus 3, they're both the same degree.
Oh.
And if the limit as k approaches infinity, if the degrees are the same, I'm just taking the ratio of the coefficients.
Okay.
So it's just, it'll be 2 over 1. It should be 2. It's like 2x squared over x squared. It's just going to be 2.
Okay.
Yeah. But yeah, essentially, I'm going to wipe these out. We know 1 over k plus 2 is going to be in that family of 1 over n or 1 over k, which is a harmonic series that diverges. And we know by comparison growth rates, we know natural log is going to be growing at a slower rate than polynomial or something in that polynomial family, but everything is flipped around the denominator, right? So if something is smaller in the denominator, it means that it'll be larger overall. And because I know that this series diverge, anything larger than a diverging series must also diverge as well. Yeah. Oh, you mean this?
No.
Yeah, natural log of k just means that it's in a different family of function. It's under the natural log family. No, because the natural log is different family. It's not in that 1 over k plus 2 family anymore. Yeah.
So 1 over any natural log of n combination will always be less than 1 over n.
Well, no, it will always be greater than 1 over n.
Or greater than whatever.
Right. Right, greater than.
How many FRQ problems are gonna be on the BC exam?
Both AB and BC will have 6 FRQs. 1 and 2 will be calculator. 3 through 6 will be non-calculator. However, this current change was not the case. I think it was like before, maybe it's like before 2010 sometime. It used to be 1 through 3 being calculator and then 4 through 6 being non-calculator, but then 10, 12 years ago, they changed it so that 1 and 2 is calculator, 3 through 6 is non-calculator. I think there's like an AB sub score for when you take a BC exam.
Like if you do.
I think,
Because isn't it combined BCs?
right.
Yeah.
Yeah, I think, whatever credit you want to get, I think you can just take the higher of your 2 scores and use it. I think. I don't know though. You have to. Right, I think so too. Yeah. -1/2 comes out a little bit cleaner because that numerator is going to turn into an alternating series. And then it's a lot easier to determine if the series will converge because all we need is to show that 1 over natural log of k plus 2, the limit of k approaches infinity, equals to 0 And that is enough for us to have a converging alternating series.
Is the FRQs from 1988, like have these like changed much or like have they?
They haven't, yeah, and I wanted to start early because by the time we get to our AP exam, we would have pretty much seen all the number 6 problems up till last year. So I remember going to Kansas City a couple of years just to help with grading. Now everything, people still go there for grading, but now all the grading is online, which is a lot cleaner, a lot less areas of mistake. But before COVID, it was all individual packets. So we would actually look through the packets and actually grade in the packet. Now they scan everything, so they're able to keep everything in order. But it's eye-opening to see students take, just being able to grade, look at problems from all over the country and see the variety of answers. And it's a very intense process because everybody has a different way of reasoning, right? And then to make sure that all the graders are consistent with their grading, that takes training. And so, it's a very good experience for the teachers to go there and to there's a lot of discussion about, what should earn a point here, what shouldn't earn a point there. And what's eye-opening when I was grading some of the BC exams was how many of the number 6s were left blank. And, as a grader, when you're doing 8 hours of grading, it's bad to say this, but like when you see a blank page for number 6, it almost feels like, okay, great, I can just move on to the next one. I mean, it's bad to, you hate to see students do that, but at the same time, when you're doing this for 8 hours a day, it's almost like, okay, good, I'm grading number 6, so I'm expecting a lot of blank pages for number 6. And I think the reason for that is sometimes smaller schools don't have AB calculus, so they just offer BC. And so sometimes they're not able to get through all the content. And so there's a lot of, schools that don't even get to series. And so they leave the question blank. And usually number 6 is also where a lot of creative answers are formed, because students, they don't know what's going on. And so they just spend the time like doing poetry, or they draw really interesting pictures, or they, go on a rant about how they didn't cover any of this material. And so, we couldn't take any photos, but we would just kind of show each other, look at my number 6. So, and I don't think, hopefully we don't, and I just remember thinking to myself, I don't want, to be in a situation where my students ever feel like they're lost with number 6. So I really want to make sure that, okay, we're really good with this. We feel really comfortable with infinite series, and we're going to be good with this problem. So okay, let's try number 3.
Is number 3 calculator on the exam?
No, technically this is all non-calculator. So typically the idea is that infinite series are always going to be non-calculator, more or less. I think sometimes they may sneak in infinite series into like a 1 and 2, like a part of it, but typically within the last like 10, 15 years, or maybe even, 20 years, I think, they've always exclusively used number 6 for Taylor series.
I was asking because like I'd rather use calculator than a bunch of chain rule, but
Yeah.
You know what? Then she like says, you know, like, a little bit of a bag. I just don't know. I think I just don't know. It's like, no, like, you had to be there. No, Marshall, you had to be there. No, like. So like, it's funny. It's like this long, this phone, like, yeah, like, I have to know with the freaking Utah, started rating these. I was like, she's watching grading AP exams like every day. Maybe she hates her freaking late classes. That's another one. That's wrong. She's so nice. You need to think it. I just wanted to send up.
For number 3, we do want to build out our Taylor series from scratch because we're not centered about the origin, and also this doesn't quite fit as easily, as cleanly into one of our known series. So safest thing is just to build out your Taylor series, and then you can put it into that that form of nth derivative of c divided by n factorial times x minus c to the n factorial, or x minus c to the nth power.
No, on the AP exam, they don't care about simplification, right?
That's right. They don't care about simplification. You leave your answer unsimplified. The first 2 terms of my Taylor polynomial will just be y-intercept and then the slope times x minus c. And then from here, from the second derivative on, I can put into this pattern nth derivative over over n factorial times x minus c to the nth power. Maybe simplifying is not required, but sometimes simplifying can help you get to the general term. So just, I think it's just up to what you would like to see or do. Okay, we will continue with this after break. So the homework is pages 1 through 6, but we can do that. We can finish a lot of it on Thursday after break. Okay, can we get your phones?
What's the general term?
Yeah, general term is,
I have to look at.
yeah, I have it.
Step by step, like the -1 just means it's alternating signs, right?
So that just means that we have an alternating, yeah.
And then, okay, it's minus is
The
that,
coefficient is just going to be 1, so I don't have to worry about the coefficients.
and then just n factorial on the bottom.
Well, the n factorial is canceled out by the coefficient up in the numerator, so that's nice.
I mean, it
That-
comes out like, it's only 4 terms, I don't know. I mean, yeah, I don't know if I should assume the n factorial. So if I leave the n factorial there, that's fine.
You want to get points off, no?
Okay. Probably,
But then if you did that, well, what did you have in your numerator?
yeah, it does. Make sense a lot.
Right, but in your numerator, if you have n factorial at the bottom, you have n factorial on top as well. That way you, in your general rule, if you have n factorial in the denominator, what did you put in the numerator?
Oh, I don't know.
Oh, okay, so you gotta have something that will be the same thing as this.
What would it be?
Yeah, they cancel it out.
Where would I put it?
That's fine. Yeah.
Oh, no, what if like minutes?
Like,